For the next few minutes, we're going to give you a short overview on our key findings in our megapixel camera versus PTZ test results. So as you saw in the opening, this is the scene that we are using. And so right at this sort of large star, we placed a PTZ camera and 4 megapixel cameras, and then we attempted to see what are the differences in quality at various points. So you see our near subject, mid subject, and far subject. In the videos, you'll see basically our subject starts out all the way at the edge of the park and then walks in across the parking lot. Now, the first question you might look at is, why did we choose this field of view? A PTZ, of course, can normally go 360 degrees, and in our setup, we've limited ourselves to about 50 degrees. So it seems to be a little bit weird, right? So let's take a look at that first in terms of what our alternatives are. Well, we could use a 360 degree camera. For instance, this is our Robotics Q24 test results. And you'll see basically our subject is about 3 feet or 5 feet away from the camera, and it's already heavily pixelated. Now let me go move the subject a little back. Now our subject is maybe 7 or 8 feet out, and you see how bad it is. We're going to go basically, our subject is about 22 feet, and you almost can't make the subject out. And this is what you get when you use a 360 degree camera. This isn't a robotics issue. If you use Grand Eye or the 360 degree cameras, you're going to essentially get the same impact because, well, you're spreading out your pixels across 360 degrees. So the pixel density or the resolution or whatever you might want it or refer to it out or envision it is going to be very weak. So it's just impossible and not even worth testing a 360 degree camera versus a PTZ in terms of range of covering. There's certainly benefits for 360 degree cameras, but it's absolutely without a question not replacing PTZ cameras. Now, the other element that we could look at is looking at a wide angle lens. So here actually this is a stock lens. This is about a 50 degree lens. It looks similar to tests we've done, but we've contrasted this to Thea. So let me show you in the Thea lens, if you're not familiar with, these are about 135, I believe, or 125 degree lenses. So this is 2.5 times wider than sort of a quote-unquote standard or traditional sort of lens or field of view that you would normally see. So let me give you the contrast here. So this is basically the cameras are in the same position, and this is our 50-60 degree quote-unquote normal lens, even though here it looks basically like the camera is much farther away, but the camera's still in the same position. It's just the optical properties of being much, much wider. So let me show you this contrast. Let me zoom into our subject over here. And so you'll see this subject, you can see a stall is about 20 feet wide, so not even 20 feet away, and our subject is already very, very blurry, right? So that's pretty close to the camera, and if we went out to, or for essentially this car, which is about 40-45 feet away, I mean, it's completely a blur. Now let's contrast this to this other scene with the more traditional lens. Let's have our subject well close. Right now our subject now at the same position, and you can already see, right, it's much, much clearer to see the details of the subject. And let me go in and take a look at this car over here, and you can see, you can make out a ton more. You can almost read the license plate. You certainly, I can't read the individual digits, but it's much, much closer on this 50 degree lens than over here on the 100 degree plus lens. So we didn't contrast it to 100 degree plus lens because it's pretty clear that you're just not going to get any type of range that will compete with the PTZ camera. So what we said to ourselves is, what if we just took a portion of a parking lot? I mean, this is a pretty big area in itself. I mean, you're talking tens of thousands of square feet to cover, and you might conceivably say, you know what, I only need to see in this area over here. You know, I'm happy basically. I don't really need to have my PTZ look back. It may be facing a wall. It may not be an area I care about. What if I was just using my PTZ to cover this type of area, this cone shape that we did here? So let me show you an overview of what we found. All right, so this red circle represents sort of the maximum distance that our PTZ, and you'll see it in the test findings, where our PTZ could get facial details or license plates from an individual or from a car. So this means that we had basically right here in the center, that's where our cameras were, and then the PTZ, when zoomed out maximally, could read license plates or the details of a person's face way out over here. These little triangles, these blue ones and this yellow ones, this represents a fixed camera. And you can see here that the megapixel represents roughly a doubling if you went to 5 megapixel in terms of distance, and obviously increases the square footage of the area, almost quadrupling. But when you compare it to the possibility, or basically the potential of an optical zoom, it's obviously ridiculous, right? It doesn't come close. I mean, you're talking on the order of magnitude of 100 times more potential. Now, of course, the big trade-off here is that the megapixel, any of these fixed cameras, what they see at, they're always capturing. The PTZ, when it's zoomed all the way, for instance, into this position over here, it isn't seeing the other 99.x% of the area. This red is all about potential. So there's absolutely that trade-off. But in live monitoring, if you need someone to zoom in and to track someone over farther distances, there's just no competition, especially in this, what we consider a normal size outdoor area. All right, now let's look at a couple of our comparison shots. You can certainly go through all the details and all the numerous ones in the result, but I'll just give you a few moments of commentary on a few of them. All right, so this basically is a new graphic we're including, and we think this will help you get a better sense of the trade-offs over distance. So again, this white star is where our cameras are at, and then here, if you look over our near subject, or where our subject is near to the camera, you can see that the 5 megapixel is almost as good as the PTZ zoomed in. And that's pretty good, right, if you only need to go out, say, 20, 30, 40 feet. But when you even go to this mid subject here, right, which is, not even more than 100 feet away, clearly the PTZ is much, much better. I mean, it's a blur at this point for the megapixel camera. Now, maybe you say, like, listen, I don't really actually need, or I'm willing to sacrifice seeing facial details if I can have sort of the broader range of coverage. So it might be good enough. When you go out to the far subject, over 250 feet, now you start seeing where the PTZ still can deliver pretty significant facial details. Even the 5 megapixel, right? It's just a blob. And then, maybe it's good enough for you to just have a blob, but if you're really trying to track someone and see who the person exactly is, it's going to be a big negative. So do keep that in mind, and you need to set the right expectations about what's going to be delivered if you try to replace a PTZ with a megapixel camera, and hopefully this image shows you the trade-offs involved. All right, let's look at nighttime. At nighttime, you're going to see basically across the board, both cameras, right, have greater difficulty, right, not surprisingly, right, because of less light, but you'll see the same pattern emerge, right? The near subject, the megapixel comes pretty close. The mid-range, right, still a big advantage, and even far out, right, you can make out some details where, I mean, even with the 5 megapixel camera, you'd be hard-pressed to know that that was a human, unless basically someone told you or alerted you that there was a human in that space. All right, let's wrap this up with just a quick review of a couple of the contrast. So this is what we were talking about, our far subject. So if you look basically in the lower right-hand corner, this red box represents we're zoomed all the way out. And again, you can see that on the digital zooms on the PTZs, which are of course the blurry ones, it's hard to really make out anything beyond sort of that there's a blob, probably a human blob out there. With the optical PTZ, I mean, you can see the logo on the car, and you can see details of our subject. All right, now we're moving a little bit closer. We're at our midpoint, and clearly the megapixel cameras are providing greater detail than they were all the way out. But on the other hand, the PTZ, right, absolutely crystal clear. If you had an operator who wanted to track someone, you'd absolutely get a great shot with an optical zoom, but you'd only get, a silhouette, some vague details with any of the megapixel cameras. All right, finally, this is the near subject, right? So our subject here is pretty close. But you can see, for a traditional standard definition camera, this is a fairly wide field of view. And you do get a fair amount of details, at least on some of the megapixel cameras. But again, the PTZ even more. But this is the really interesting one. We're going to be looking at this in future tests. When you get basically into a field of view, or horizontal field of view of 30, 40, 50 feet, That's where Megapixel basically provides you almost as good detail as a PTZ, but a much broader range without the trade-off of zooming out and not recording areas because you're zoomed into one specific spot. But on the overall use in a parking lot or in these wider areas, there still are very significant trade-offs that must be factored in when considering megapixel cameras versus PTZs. Thank you.